Welcome, everyone, and thanks for joining us today on our webinar where we're going to be focusing on encryption with our title here, Streamlining Data Encryption, while also maintaining your IBM availability for all those mission-critical applications that you have running there. I want to introduce myself. I'm Bill Hammond. I work in the product marketing group here at Precisely, and I cover all of our Assure security products as well as other IBM products and mainframe products we have here in the Precisely family. And I'm joined today by Bill Peedle, who's a principal sales engineer for us and is just involved with a ton of different customer interactions, working with customers on solving their problems. And he's pretty much an expert on this whole topic that we're going to be talking about today. So I'll be working with Bill on the content for you today. So as we move into the agenda, I just wanted to cover that for everybody. Before we get started in the actual topics here, just a quick reminder, you don't need to be taking copious notes or screenshots. You will get a copy of the recording afterwards as well. So you can kind of sit back and listen as it is right now and always be able to replay the recording you're going to get later. And we'd also encourage you, if you have other colleagues you think will be interested in this content, please forward that recording you get to them. So again, thanks for joining. And here's the topics we're going to kind of use to run through this presentation today. I'm going to talk a little bit about, what is encryption, the benefits, why are we doing it? What do you need? What are we using this capability for? And then some of the challenges that are inherent in encryption itself, some specific to the IBM environment. And then I'm going to hand it off to Bill, and he's going to spend a little time talking about different strategies to use for encryption, and I'm focusing a little bit on the field level encryption capability of IBM, and that's kind of a unique capability the IBM has. And then we want to close it off with what we call our Encrypt While Active option, and it's a real a slick solution for people that need to encrypt their data but are worried about the downtime or the impact it might have on their environment. So with that as a bit of the preamble, I will go ahead and kind of dive into the actual content for you. So I wanted to take one slide and just kind of get on the same page with everyone about, what is encryption? And simply put, it's the process of changing data into a format that is unreadable by somebody else. It says here it's known as ciphertext, but it's the way that we use to protect really sensitive, like personally identifiable information, data that is, really proprietary, whether it's technical data or customer data, things like that, from unauthorized access. Even if somebody were to get access to it, they wouldn't be able to use it. They wouldn't be able to read it or understand what it is. That's what data encryption really is all about. And the way you accomplish it is by using a fairly standard encryption algorithm and then a key to unlock it. So essentially, it's like a lock and a key. So you lock it up and you keep the key, and then if you need to uncrypt that data or decrypt that data at some point in the future, use this key to do it. And we'll talk a little bit about how you manage those keys and what they really mean. But essentially, that's the metaphor. It's a lock and a key, and even if you were able to get to the door of that data, you wouldn't be able to unlock it to actually see what it is. That algorithm I mentioned is just a mathematical formula that again, changes that data from its normal format into something that is unreadable by somebody else unless they have the key. You can't get into the door unless you have the key, extending the metaphor. Okay, so why do you use encryption? There's a number of different reasons. You can see here there's data protection elements. A lot of people, and more people every day, seem to be falling under compliance and regulatory issues. And that data protection element really is designed to make sure that you're protecting your brand, you're keeping your customers in a position where they trust you with their data, and also for competitive advantage or even competitive parity out there with the people that you're competing with in the marketplace. So on the data protection side, you're really concerned about confidentiality of that data. And again, I mentioned like personally identifiable information. That's kind of the poster child example for that. But there are other pieces or types of data that you need to be worried about. You need to make sure that as you're encrypting and decrypting data, that you're going to make sure that it is unalterable. That's going to become an issue in the compliance side of things as well. And then also, you want to make sure that your data is available to the people that need to use it, but not going to be co-opted or stolen and then used as part of a ransomware attack and have you held hostage and paying a bunch of money. There's been some recent examples of people that actually did get hacked and had to pay a pretty large sum for unlocking their data from the bad actors. The compliance side of things, like I said, more of these are happening all the time, but some common ones that your company is definitely going to be concerned about. If you've got employees, you're concerned with HIPAA. That means keeping people's medical information private if you do have it. GDPR is a privacy regulation that is very visible and prominent for a lot of people that contact their customers via emails and different things like that. California Consumer Privacy Act is really, again, sort of in the GDPR angle. But different industries have different compliance regulations that they have to deal with. And in a lot of those cases, encryption is one of the key elements of being compliant with those standards. Brand reputation and customer trust really is when you look at, I mentioned before, some of these companies that have had their data hacked into and had to pay a ransom. As a customer of those companies, I start to wonder, is my data safe in their hands? Should I be worried about the data that I have shared with them? Could that data possibly be used in a way that's going to be harmful to me? Or worse, even more common, use the data they were able to steal from that company and get into my data in other companies. So customer trust and just the reputation around how you handle your customers' data can be really, really important. And then competitive advantage, I sort of tease the intellectual property, kind of the things that you want to make sure you protect that are very valuable to your company. Besides your customer data, you might have technical data or contract data or things like that that you want to protect. So competitive advantage can come into this as well. So there's a number of reasons, as you can see, for why it's important that you want to protect your data by using some level of encryption. When you start looking at, what is encryption, what kind of standards are there, what should you be using? Our recommendation is always that you're using the Advanced Encryption Standard, AES is what that's talked about. NIST, the National Institute of Standards and Technology, is another standards body that recommends that as well. The U.S. government have accepted the AES standard as the standard that they're going to use with protecting their data. A lot of the specific regulations that I mentioned before will call out AES as the preferred encryption method. And recently, the Advanced Encryption Standard has sort of been upgraded to AES-256. And we certainly recommend you step up to that. There's some advantages in terms of some of the coming challenges that quantum computing will bring to the security landscape. And AES-256 is a great step toward making sure those potential problems aren't going to be problems for you. All right. When we talked about that lock and key metaphor I was mentioning before, the question becomes, so where do I keep this key? Or what is this key? And really those keys that you use to then unlock or decrypt the data that you've encrypted are generally kept on what's called a key management server. So you need to consider what you're going to do with that. And most customers use an external key manager to store and manage the master key as well as those individual lock keys that you need to have. A lot of people may already have a key manager that they use on other platforms outside of IBM, but you can go ahead and use that. There are also a lot of our customers talk about using the Alliance key manager or the Cipher Trust one there. But there was other ones as well. But the important thing is use a key manager, trying to keep track of this. And I'll talk about this a little bit in the challenges. Trying to do this any other way than a dedicated key manager becomes really, really challenging. And for those companies who really rely on their IBM, they're concerned about it, and they don't want to use a key manager running on a Windows or a Linux server for whatever reasons, you can use the IBM to store and manage the keys too in a local key store that actually is on the IBM itself. So that's where you store these keys that you use to unlock the data that you've locked up. Again, kind of that lock key metaphor. Couple of last final points here, though. Protect your encryption keys and data. You have to keep them separate. You don't want to keep your encrypted data in the same location that you keep the keys for decrypting that data. You see the metaphor like placing the house key beneath the mat. That's not a very secure um, property protection approach, and it's not secure when you think about it as a data protection approach as well. So the best practice really says store the encryption keys separately from the encrypted data. So there's an air gap between those two things. So somebody who does get access to the data isn't also getting access to the keys themselves. That those are kept separately with an encryption key manager. So you don't want to keep the keys and the locks, if you will, in the same place. That's just kind of standard security approach on that. So now I talked a little bit about how I'd spent a little time talking about encryption challenges, and I'll get into a little bit of best practices too. But if we start to go down that path, let's talk a little bit of the area of challenges that people wrestle with when they're starting to think about encryption. I just spent a few minutes talking to you about key management and talked about what a great idea it is, but it doesn't come free, or it's not automatic. There are issues around how you want to do that key management. Even in the world where you're using a key management server that can help you accomplish these things, there's a lot that you have to worry about with how your key process really is going. Lifecycle management being the number one I listed here. Keys get created, they get destroyed because you don't need them anymore. So you're managing those keys in kind of an active living sort of way. So you need to be concerned about the process to generate them. The distribution's a big thing. The keys aren't going to be secure if you're giving them out to everybody, or if everybody has access to the key, that lock isn't doing you any good. So that's a really important thing. You want to be able to control how and who gets used to use those keys. You want to honestly change those keys periodically. So rotating the keys is an important thing. You need to regularly change those keys. And that's just a way to mitigate the potential risk of having those things compromised. Revocation really is that key no longer works. And that's periodically something that you should be doing when it's no longer needed. And then finally, if you're not going to need this key anymore, instead of just like deactivating it, you want to just get rid of it. So destruction. So there's all these elements of managing those keys over their life cycle. And you want to be considering that as you're implementing your encryption standard. Again, coming back to the compliance thing, there are those standards that you may have to meet in different, HIPAA I mentioned, GDPR, PCI DSS, which is all about credit card transactions and things like that. They will have strict mandates about how those keys are handled and do get managed, and require audit trails for how that goes on. Another element of key management is just the human error element of it. You could accidentally disclose the keys through some, stupidity on your part or someone else's part. So you need to try to mitigate the human error factor, whether it's, again, the accidental disclosure, losing the keys, things like that. So key management as a consideration with your encryption is a really important sort of concern. Moving on to performance, there is an element of encryption that we need to all understand, is that it is a process. It requires processing power. So it is something that you need to consider the bandwidth capabilities that you really need to be effectively being able to encrypt and decrypt data, and do it in a world where it's not holding up your application performance and things like that. So these algorithms that are used to encrypt the data and decrypt the data are computationally intensive. So we need to consider the hardware concerns or needs that will take. So that's an important thing as well. You also need to be looking at making sure you have the bandwidth between to do the data transfer between the encryption and decryption, getting that key over there, getting the data decrypted. If you have a tremendous network latency, it's going to take longer to do that. It's going to be impacting users and things like that. Same thing with storage. If you've got a slow storage kind of array, you are retrieving those keys and encrypting stuff, using storage. So the performance of your storage is something you want to take into account as well. And then finally, just your application performance. Again, under all those elements. You need to be looking at that database queries, things like that. So decryption and encryption can have an impact to put a load on the system that isn't there before. So you need to be thinking about making sure you have the overhead to support it. Security and usability, and obviously, encryption is part of an overall security strategy, but there's a security element to your encryption implementation as well. So, the algorithm selection, I kind of spent a little time talking about what we recommend there, but that is, a challenge to make sure that you're picking the right one. Weak ones are not going to give you the kind of security and protection that you want. I mentioned quantum computing, and in a nutshell, what you're worried about there, and it's kind of a future worry, sort of like worrying about year 2000 when we were in 1997, but quantum computing is going to be a step up in processing power to the extent that some encryption algorithms that are in use today could be broken by the quantum computing capability. So just something you need to keep in mind, nothing you need to react to today. And again, AES 256 is going to be very, very helpful and usable there. The user experience, to make sure the right people can get the keys they need and access to the encryption and decryption process, but you're not giving that to people that don't need it. So making sure that that's something you're keeping in mind as well. People have different encryption standards running around their environment, and making sure that you have compatibility between the standards and the implementations is important as well. And then managing access to the keys themselves and the encrypted data, because you want to restrict people that don't need to get to that data. Even if they don't have the keys, you should be trying to keep that away from as well. So just an element of access management as part of the security issue there as well. So the strength and the length of your keys, excuse me, again, are very important. The longer the key you use, the stronger the encryption algorithm, essentially. And you're balancing the fact that higher levels of security there is going to require more processing power. So it can impact the performance and the responsiveness there. So all in all, better or longer length is better, but you do have a performance consideration you need to consider there. And then strength of those keys, you want to make sure you're using those robust algorithms. And going back to the key management strategy, you don't want that to be a bottleneck either. You want to make sure that you've got an effective strategy there for getting the keys to the right people when they need them for use, and unlocking and locking those files. Some additional considerations kind of in this key length and strength, the threats, you want to assess potential threats, and then, the level of protection that you uniquely may require based on your data, your industry, all those kind of things. Again, which of those compliance regulations are going to be important to you, and make sure you're making the right choices based on what you're going to need there. And then as your needs are going to grow just normally as a company for performance and more storage and those kind of things, you need to be considering the fact that your encryption strategy needs to also be taking into account future needs and growth as well. And then finally, the last challenge I really want to talk about is not so much the day-to-day challenges you need to manage. The first four were kind of like, once I've got encryption running, these are the things I need to worry about. This last one is like, okay, I want to go from I'm not encrypting my data to I am encrypting my data. And what are some of those challenges? So there's some that are on the technical side. The performance piece, you need to consider that up front. The integration, making sure you've got incompatibilities between the algorithms they're using, making sure you're selecting the best algorithm you possibly can, and then implementing that. And then also making sure that, if you need to recover data, if those encryption keys are lost or corrupted, you need to consider what you're going to do in that case as well. On the other hand, besides the technical challenges that you're dealing with when you go to implement encryption, there's some organizational challenges that are going to be considerations as well for you. Costs. This isn't free, both even from the standpoint of implementing the encryption algorithms themselves and making sure you've got a product that can do that for you. But some of these performance things could actually lead to, extra spend on hardware and those kind of things. Mitigating human error as much as you can by processes and controls that you implement in the environment to restrict as much as possible human error. Organizationally, having to meet the challenges of a compliance regulation, the implementation of encryption may be one of many different things you'll need to undertake to meet that compliance regulation. So it's usually there's no compliance regulation. It's just an encryption compliance regulation. They're part of a larger set of rules that will get you that compliance. And then making sure your users are trained and can accept what they're going to need to do, because there's going to be some things they're going to need to do differently in a world where everything's encrypted, where it isn't. And then finally, kind of going back to the first four that I was talking about, balancing all of the tighter security is great, but I need to make it usable for my customers, my users. So balancing those two things against one another is a key piece of that as well. So kind of summing up my part of this with the implementing encryption in IBM I. In IBM I, there's a couple of things in the way that operating system works. The data that you may need to encrypt, there's very possible that you might have an exclusive lock on the file, which means you won't be able to encrypt it or decrypt it. So getting around that is an issue. Because of the mission critical applications that run on IBM I, you don't have huge windows to do things like encryption and doing them all in a small amount of time, like encrypting everything in this system or this LPAR or whatever. You might not be able to do that. So how do I implement my encryption if I don't have the time to actually go through and do those kind of things? So the small window that's really due to the mission critical nature of those IBM I applications and workloads is an issue there as well. And then you don't want to risk application issues once you do get things encrypted, because again, these applications that run here need to power the business. So making sure that the encryption implementation doesn't risk your applications having problems, going down, not being accessible to your users. Those are some unique challenges that you want to make sure you're considering in the IBM I space. So with that kind of a high-level flyover of why encryption and what some of the challenges are, I'm now going to hand it over to Bill Peedle, and Bill's going to talk at first about comparing the different kinds of encryption strategies that you may be considering. So Bill, I'll hand it off to you.
All right, thanks, Bill. All right, so yeah, let's take a look at the different strategies. Go ahead and move the slide up one, please. All right, so there are other technologies. There's several technologies out there that you can use for encryption. One common one is disk level encryption. So what that does is it's full disk encryption. It allows you to encrypt the data that's stored in disk pools, basic disk pools, or independent ASPs or independent disk pools. Full disk encryption protects data from a couple of different threats. One of them is data transmission to and from the drive. The other is data transmission in a cross-site mirroring environment. And then it also protects, most importantly, against the theft of a disk drive. So if somebody was to get their hands on your disk drive, you just did an upgrade to your system. Whoever did that forgot to wipe the disk, and then you're going to send everything back to IBM, and all of your sensitive data is there sitting on the disk for somebody to take a look at. Next slide. So there's another way of encrypting data on the IBM I, and it's field level encryption. This uses a technology that's built into the IBM OS, which is field procedures. And what they can do is they can encrypt data at the field level for DB2. Now, what that means is that not every single field in a given file would be encrypted. It would only be the fields that you deem to be sensitive, PII, PHI, credit card information, things like that. It's actually a user-written exit routine to transform values in a single field or column. So when a value in a field's changed or new values are inserted, the field procedure is invoked. So basically, anytime there's a database operation against that field, it's going to invoke the field procedure. So then the field procedure, when it's being touched with the database operation, it actually decrypts the field so that the data is usable for the application. So from an end user perspective, they would most likely not even know that the data is encrypted because they're going to see it just the same way that they used to. But it is encrypted at rest when it's sitting on the disk. So when the values are retrieved, the field procedure is invoked for each encoded value. It's decoded back to the original value for use. And that could be interactive. It could be a report. It could be an SQL statement. It could be DBU. And then any indexes that are defined or keys that are defined on a field that uses a field procedure are built with those encoded values. So the fields are encrypted at rest. That's an industry term, and they'll be decrypted automatically via a database operation. And then one of the major benefits of field level encryption is that you can mask data. So not only would the data be encrypted on the disk, it can be masked so that you can have certain users that can't see the data at all, and other users that need to see the data, it can be decrypted and unmasked. Next slide, please. So let's talk a little bit about field level masking. So as I said before, this is one of the bigger benefits of field level masking. So I'll use a social security number, for example. Only certain users or groups can see the fully unmasked social security number data. So when I think about social security number, I immediately think about maybe this is the payroll administrators. They should be able to see it. They need to work with that information. But really, nobody else should be able to see that. So other groups can be masked to see only the last four, or you can mask and say, I'm just going to mask the entire field. The last four, everything but the last four is kind of an industry standard. But if you really want to make sure that it's just completely masked, and people that like developers or other end users that may have access to that file, but you don't want them to be able to see that field anywhere. It'll come out masked on reports. It'll come out masked interactively, any place that you touch that data. If you run a SQL statement against it, still masked. So let's use the social security number 1 through 9 as an example. So for like a payroll administrator, the field would just get encrypted, and it would get decrypted when they were looking at it. Maybe they're looking up in the employee master file, and then interactively they get to see the full number. For the other users, you could do, which is one of our options, is to mask the first 5 digits or expose the last 4. So in my example of 1 through 9, you're going to see, then this is a character. I'll mention that this is a character social security number. You can pick whatever whatever character that you want to use to do the masking. So in this example, I just picked X, but you could use asterisk. You could use any other character that you want. They're going to see 6, 7, 8, 9. That's it. And then 5 X's. If you have other users that you want to mask the whole thing, they're just going to see 9 X's. Next slide, please. So if the field in question is numeric field, because you can also have numeric social security numbers, the mask will actually be the number 9. And I had mentioned before that the character, you get to pick what you want to use for that. So let's look at a credit card, and this will also be a character example. So I just went ahead and started with 1 up to 9, then started with 0 back to 6 again, just to simulate a credit card number. Now, if we decide to mask everything but the last 4 digits, you're going to see all X's up to that last 3, 4, 5, 6. And if you decide to mask the entire field, it'll just be all X's. And again, that's on a user by user basis, or you could do it by groups or things like that to make it a little bit easier if it makes sense. Next slide, please. So let's talk about field level encryption on the IBMI a little bit deeper. Next slide, please. So what does it look like on the IBMI? So if you're a database administrator or a developer, you're probably pretty familiar with the display file field description command. And this is an example of me doing a display file field description on a file called ancust, and it's in a library production. So if you look at it, and again, this is on the green screen, you see your normal typical things. You'll see your field name, data type, the length, column heading, text, and then CCS ID. Okay, nothing special there. Next slide, please. Once you start encryption on a field, you're going to see some extra attributes. Same command, same file, but now I've got, you'll see at the bottom here, field procedure name, which is the name of the field procedure program object, and then a field procedure library, right? And so we recommend that when you build these field procedure programs, they need to be there. You can't delete them. And if you're doing high availability or disaster recovery with a product like Mimics, it makes sense to put that program object in the same library where the actual file that contains the field lives. That way you don't lose track of it. It gets picked up automatically and it gets replicated over to the target. So that way when you need to do a role swap, planned or unplanned, you can still work with your data over there. You would obviously have another copy of our encryption software installed there and ready to go and licensed. And then Mimics would take all the configuration and replicate that over, and it would also replicate over the field procedure itself. Next slide, please. So how do I do the encryption? Right. So field procedures, as I mentioned before, they're part of the IBM iOS. It can be used for other purposes. They're a program, right? So if you had a use case, there's nothing stopping your developers or any developer from writing a program to do something every time a field gets touched. But they're primarily used for encryption and masking, in my experience. So a field procedure is a procedure. It can be written by hand and attached to a field, but that's a pretty large undertaking. Number one, you have to have somebody that has that expertise to be able to do that. You have to execute an alter table to attach the field procedure to the field. So, and then you need to keep track. As you start encrypting more and more fields, you start losing track of where, what have I encrypted, things like that. So the best way to encrypt and decrypt fields is with a third-party interface that'll develop the code for you. It'll attach the field procedure to the field in question, and then it has a nice interface to manage and track which fields are encrypted or decrypted. And you can also set up the masking rules at that point. Next slide, please. So there are some implications for field level encryption, and Bill touched on some of these, but I'll run through them again. When you're encrypting a file or decrypting a file, you have to have an exclusive lock on that file until the encryption or decryption has completed. Now, if it's a small file, and I've seen this in the field, where it's very small files, they encrypt or decrypt very quickly. So that initial encryption, you might have a window where you could just quickly get in there, start the encryption before a user gets a lock on that file. But that's not ideal, right? So that is one of the challenges, and we have a solution for that. I'll be talking about that here in a couple minutes. Then if you have the requirement to roll the encryption key periodically, what rolling means is you've used a key for 6 months or a year, and just for security reasons, or you're being asked to maintain compliance that you have to roll the key every so often, you have to decrypt with your current key and then re-encrypt with a new key, right? So now it's a double hit. It's going to take twice as long. Whatever it took to encrypt that, now you have to decrypt it and re-encrypt it. So we, again, have a solution for that. And then for, this is a little bit more of don't see this as often, but for customers that have legacy RPG ILE programs, so they've had an RPG on their system for many, many, many years, maybe 20, maybe 25, and they've built their own custom code, and it's working for them, and they have no intention of changing what they're using to the code that they use to write those programs. Then they're going to could run into a situation where if they encrypt an index or a key on a file, right? So let's say it's social security number, and that's the index on that file. The sort order now is based on the encrypted data. So kind of the garbled data, right? Not the actual values, like I showed earlier when I showed the social security number example. So when say a payroll administrator brings up the employee master file interactively, and it's sorted by social security number, but when they look at it, it's not sorted by social security number anymore. Well, that's because it's sorting on the encrypted data. So there are technologies that can help overcome that situation as well if you run into it. Not everybody needs it, but it's worth talking about. Next slide, please. So let's talk about minimizing the downtime required to encrypt or decrypt fields. We have a technology that allows you to do what we call encrypt while active. And basically the way that it works is you make a copy of the file that you want to encrypt out of production. using the create duplicate object command into a temporary library and do it without the data. So you just have the shell, then we can start encryption on it. And now it's empty and it's encrypted. The Encrypt While Active technology will then copy all the records from the production copy of the file into the temporary copy. And the problem that solves is the production copy can still be used by your end users. So you're not taking 30 hours of downtime to encrypt a very large file, right? This is now going to happen in the background. So, and as the records are being copied in, the fields in the records are being encrypted automatically via the field procedure program that's attached to the file and the field. So, and the best part about it is this technology keeps the file in sync with ongoing changes, since the file is still being used by end users and applications. Now, if we didn't keep track of those changes and apply them or keep it in sync, it just wouldn't make sense, because whatever happens since I copied that file out in the first place is going to be lost, but not with the Encrypt While Active technology. That will keep things in sync, just like our Mimics product does. And it's actually part of our Mimics technology. Next screen, please. So you can let this run as long as you want to. There's actually a screen where you can watch the status. It'll tell you the percentage of records copied. It'll also keep track of the events, which are new adds, changes, or deletes. And once you have a maintenance window, and it doesn't have to be a real long one, and users are out of the file, maybe this is your Saturday night window from 8 to 10 p.m. or something like that. There's a process that we stop keeping the file in sync. We call it idling. While it's keeping it in sync, we end that idle, and then the old copy of the file can be taken out of production and put into an archive library, and then the new encrypted version of the file can be moved into production. We recommend using the move object command because it simply updates a pointer on the OS. It doesn't physically copy data, which means that if it's a 100 meg file or if it's a 2 terabyte file, it takes the same amount of time to do a move object. So it's very quick. So the Encrypt While Active technology can save many, many hours of downtime on initial encryption, but also I had talked about rolling keys before. Well, during that, you're going to take double downtime, right? You're going to do the decryption, then the re-encryption, so you can save time there too. Same process, just kind of in reverse. We're going to take the encrypted copy, decrypt it first, re-encrypt it with a new key, and then we're going to move it back into production. Next slide, please. So what can you do if you have legacy RPG ILE programs that don't sort correctly anymore? And I typically tell people, if you're not sure, it really, when you're doing something new like this encryption, you should be testing this out in some type of a test or a lower environment first, just to kind of plan for what you're in for, timings, things like this, where, well, I encrypted a key and now all my data is sorted incorrectly. So there's definitely technologies to help with that. And they do require access to your source code. So if you happen to buy a third-party software package from a vendor, hopefully they gave you the source code, or you can get the source code, and because you're going to have to add an F-spec to your RPG program. I'll show you what that looks like here in a second. And so the handler software is used to convert traditional record-oriented file access to SQL query engine, which is SQE for short. And that solves the problem. SQL understands encryption, so it sorts correctly. And again, only one line of code is added to make this conversion. Next screen, please. So this is what the additional line of code would look like. You have an F-spec, and then you have the handler, and then you see field procedure handler, file handler. So once that's inserted to the program's recompiled, you're converted over to SQL access from record-oriented reads, and the sorting issue disappears. Next slide, please. All right, so let's talk a little bit deeper about Encrypt While Active. We touched on it, but I want to go into a little bit deeper level. So what it does is it really combines our market-leading Assure technology. We create a pre-production copy of your encrypted data, promote that file to production with only minutes of downtime, And one added benefit is we can also compress deleted records out if you want. It's not mandatory, but it's nice to have. This technology is based on our Mimics Enterprise that we use for HADR, or high availability disaster recovery scenarios, real-time replication or near real-time. And then Mimics Promoter, which is a sub piece of Mimics. And that's what we use for the file promotion. And then our Assure Encryption, which is what we use to actually manage the encryption and decryption on your IBM I. And then it's a combination of software and services. You're not on your own. Obviously, we would help you install the software, get it licensed, and we have services professionals, both on the Mimic side and on the security side, that can help with the services side of that. So next slide, please. So real quick, this diagram looks a little complicated, but it's actually pretty simple. If you're already running Mimics, you've got a production system, and we call it source over here on the left, target on the right. You're going to replicate your production, I'll call it database or libraries, over to your target system so that they're there for a failover for whatever reason, planned or unplanned. So what we do is we create two more libraries, one called archive and one called temp. And when I was talking earlier, when you take the production copy into a temporary library, that would be temp. Now that is also included in replication. And then when you're done with your encryption and you're going to move back into production, you'll take the real, or I should say the old copy of the production file that's unencrypted and move that into archive. That's also in the replication. The reason we do this is because Mimics is smart enough to know when I do a move object from temp to prod, it's just going to do a move object from temp to prod on the target. It's not going to have to replicate the entire file. It's not going to have to sync a file up. Things like that can take time. So when it's all managed under the covers of Mimics, we're able to not only help with your encryption and make that less downtime, but we're also not going to break Mimics. All right, it's going to work together with the process and keep everything in sync on the target. So it's ready to go. Whatever state it is over on the source, that same thing is going to be happening over on the target. So what this takes is installing Mimics HA. If you don't already have it, we have a lot of Mimics customers, and I work with them every day, as it relates to security as well. And that includes Mimics Promoter. Now we can also install just Promoter. If you don't have Mimics already, you don't plan on having it, and you just want the encryption while active solution, we can certainly do that as well. And then you're also going to install Assure Encryption on both systems. And then all the systems are going to be licensed for our software. We're going to create that temp in the archive library shown in the chart. We're going to create the empty duplicate objects into the temp library. It's worth mentioning that you need to take into consideration any related files. The reason we recommend that you create dupe objects on those as well is so the access paths get built while we're copying your data into the encrypted copy of the file. And any join logicals as well, physicals that are joined by a join logical. And then we'll configure Mimics for replication to the target system, use Mimics Promoter for moving the production copy of the data into the temporary library, and then configure Assure Encryption for fields that we want to encrypt. We'll start encryption on those in the temp library, and it's very fast. Next slide, please. And then we'll start our copy active file command. That's actually our encrypt while active or promoter command. And if you want to remove the deleted records, sure, we can. Mimics Promoter will copy all the records from the prod to temp, and then it's going to wait for changes or apply changes as they happen. And the fields in the records get encrypted as they're copied into the temporary copy of the file, because we already started encryption on that. So when you get to the point where you want to move this stuff into production, we call that cutover. During an outage window, we'd make sure that promoter is ended, right? So we'd stop idling on that file. We're not going to keep it in sync anymore. Your users should all be out of that file at this point. The prod files get moved to the archive, and then the encrypted files in temp get moved into the production library. And then we go into our software and we just update the field procedure definitions to now reference that we're no longer in temp, we're now in prod for this particular file. And Mimics HA replication is in place. So during this process, if anything went sideways, let's say your system went down hard, you ran out of disk space, you lost a disk, anything, power went out, um, you've got everything over on your target system, and you can kind of pick up where you left off. Next slide, please. So encryption while active, it's useful throughout the lifetime of your encryption project. The initial encryption, that's the big one, where we need to add the encryption to the fields in the files that are currently not encrypted, and that's the one that can take a lot of time. Now, if you want to remove encryption for some reason, maybe you changed your mind, you encrypted a field, and now you feel like you shouldn't be encrypting it, then you need to decrypt it, right? Well, you can also use Encrypt While Active for that if it's a large file. And then the key rotation that we were talking about, or rolling the keys, that's going to be a decrypt of the encrypted copy of the file, and then a re-encryption with a new key, and then move back into production. So it's relevant all the time, right? Anytime you're dealing with encryption, you may need to use this technology if the file is large enough. Next slide, please. So the benefits of Encrypt While Active is we minimize downtime for encryption operations. And we understand, we're an HADR company with Mimics. We understand that downtime, well, for a lot of customers, it's just they can't take it. And there's very limited windows, especially for 24/7 shops. So it definitely helps with that. Mitigates the risk of an application failure after encryption. And we can also ensure your HADR readiness throughout the encryption process, right? We don't break anything while we're doing the encryption. And again, optionally, we can compress out records with our Compress While Active service as well. Next slide, please.
I think that brings us to the question and answer period. Bill, thank you very much for that description there. It was nice to break it down with the chart at the end to kind of see where the data flows went. So let me look over and see what questions we received during the course of the webinar here. Okay, we have a couple. Here, I know the answer to this, Bill. I'm going to throw it to you for the better answer. It seems like Encrypt While Active needs replication. Do I need to own Mimics to take advantage of Encrypt While Active?
No, the answer is no. I think I touched on that. And so if you have Mimics already, that's great. We can leverage that. And then we also really want to make sure that we keep you in sync during that process. But we have standalone copy of the promoter product, which does the Encrypt While Active. That can be installed separately. If you have no interest or need for HADR, doesn't matter. We just do it all on one system and follow the same exact procedure. We just don't have to worry about knocking anything out of sync because we're not doing any replication.
Okay, that's good. Yeah, I think that question may have came in during the early part when you were talking about Encrypt While Active before you got to the last section there where I think you hit on that. But here's another one. This one may be hard to give a black and white answer to. Can you suggest any rules or guidance on trying to determine what to encrypt and what to ignore?
Yeah, I mean, in general, I get that question all the time. There really is, as it stands now, there's no tool that just magically goes out and says, "Hey, this field is important to encrypt." My thought on that is always, well, if you have your DDS for your files, and you can go through PDM and you can kind of search for SSN or credit card or whatever. And I know that's not perfect, but that's one thing that comes to mind for me, being used to be a developer, so that always comes to mind first. But the other thing is having the application owners or the database administrators that understand your application, because your application could be written in-house, it could be off the shelf. It's hard to say. We've got kind of, at least from a replication standpoint, we've got best practices for certain different types of applications, but it really comes down to somebody needs to figure out, what's important to me. I mean, the obvious ones are social security number, credit card numbers, anything else that can be considered PII, PHI, those should be encrypted. And I've had customers say, "Hey, our pricing information is our biggest concern. We don't even have social security numbers or credit cards." So it could be something that's specific or unique to your business, right? So we certainly can work with you on that. We can help in any way we can. We can have discussions about it. You know, we can get on your system and maybe help you eyeball to try to figure out what it is. But ultimately, most customers come to us with a list of what they want to encrypt already, right? And they're familiar with their database.
All right. Thanks, Bill. And as we wrap up here, Bill, again, thank you for your presentation today. Very informative. I hope everyone out there gained some knowledge here that they didn't have and enjoyed the presentation. If you want to reach out to us about this topic or really any other, we're more than happy to talk to you. You can reach out to your Precisely rep, or if you don't know it, you can get to our precisely.com website, and it's very easy to get contacted by us from there. So just put a request in, and you can even chat with someone on the website if you have a question. So please do reach out if you've got additional questions. We'd love to help you out with this problem or related problems around this. So thank you all again for your time today. I'll go ahead and close off and just say, I hope we see you on our next webinar. Thank you.